Okay friends, welcome back. Let's see some more questions on the convolution. Question number 28. Question number 28. What it is saying that if h of t is equal to delta t minus 1 plus delta t minus 3, then the value of step response at t is equal to 2 is okay. Options 1, 0, minus 1, 4. So that is what they have. Try to think about the question, what you can make out of it. Let's say h of t is given. They want to find out the step response. We know how we can calculate the step response from impulse response, which is nothing but integration of impulse response. So if I try to find out the integration of impulse response, I can get step response. So s of t is equal to integral minus infinity to t h of tau d tau. So what is the integration of impulse function is nothing but u of t. But what is the integration of delta t minus 1 is nothing but u of t minus 1. So we know this integration, let's say differentiation of u of t minus t naught is delta t minus t naught. So in the similar way, integration minus infinity to t delta tau minus t naught d tau is equal to u of t minus t naught. Both are same. So here the integration of impulse delta t minus 1 is u of t minus 1 plus u of t minus 3. So this is what the s of t we got. They want to find out at t is equal to 2. So s of 2 is equal to, suppose if t is replaced with 2, u of 2 minus 1, which is u of 1, plus u of 2 minus 3, which is u of minus 1. So I know these values. U of 1 is equal to 1. What about u of minus 1, which is equal to 0? U of minus 1 is equal to 0. So finally this is 1 plus 0, that is 1. Option A. Option A is correct. Okay, take it. Let's see one example. X of t is equal to e power minus 4t u of t. H of t is equal to u of t minus 6. Then find y of t. Okay. This is a very simple thing. Y of t is nothing but x of t convolution with h of t. X of t convolution with h of t. That means e power minus 4t u of t convolution with u of t minus 6. That's what we have to find out. So let's see. We know that e power minus 4t u of t. Convolution with u of t. I already told you it is in the standard form. You can directly write the answer, which is nothing but 1 by 4 1 minus e power minus 4t u of t. That is what it is. So what is y of t? Which is e power minus 4t u of t, convolution with u of t minus 6. Then output is also delayed by the same amount 6. That means wherever t is there, that has to be replaced with t minus 6. So in that way I can get 1 by 4 1 minus e power minus 4 into t minus 6 into u of t minus 6. So this is what we are going to get final output. Okay, take it. Let's see next question. Question number 29. X of t is equal to e power minus 2t u of t plus delta t minus 6. H of t is equal to u of t. Then the amplitude of output, then the amplitude of output at t is equal to 4 is, at t is equal to 4 is. That's what we have to find. Okay. So we have to calculate y of t. In that y of t, we have to take t is equal to 4. Then what is the value it is going to be? X of t convolution with h of t, which is e power minus 4t u of t convolution, plus delta t minus 6. This whole thing has to be convoluted with u of t. Now let's see. U of t convolution with the signal. A signal is convoluted with u of t, then we have to take the integration. This is the standard form, we know that. 1 by 4 into 1 minus e power minus 4t u of t. Next, delta t minus 6 convolution with u of t. Any signal convoluted with the impulse function is going to give you the same, but we are having the time shifting that has to be inserted. So this is going to give you u of t minus 6. So that's what the output we got, y of t. Now at a particular instant t is equal to 4, we require to find out what is the output. At t is equal to 4, so y of 4 is equal to 1 by 4 1 minus e power minus 8 u of 4 plus u of minus 2 t minus 6, that is 4 minus 6 u of minus 2. So u of minus 2 value will become 0 because step function for negative values is 0. Then finally what we are left with? 1 by 4 into, sorry, actually this is minus 2, sorry, please, it is given as e power minus 2t, so this is going to be 1 by 2, this is going to be 1 by 2, this is going to be 1 by 2, please make the change. This is 1 by 2 and this is u of 4, yeah, u of 4. So this is going to be 1 minus e power minus 8. So finally this is approximately equal to 1 by 2. How? Because 1 minus e power minus 8, e power minus 8 is almost all equal to 0 because it is a very low value. So 1 minus almost all equal to 0 is 1 only. So it is approximately equal to 1 by 2. Okay, take it. The step response of an LTI system is cos omega naught t u of t, cos omega naught t u of t. Then the impulse response is, then the impulse response is options are given. Option A, minus omega naught sin omega naught t u of t. Option B, minus omega naught cos omega naught t u of t. Option C, delta t minus omega naught cos omega naught t u of t. Option D, delta t minus omega naught sin omega naught t u of t. Okay, so these are the options they have given. So let's see what it can be. They have given step response S of t. How much? Cos omega naught t u of t. They want to find out h of t. So we know the relation between step response and impulse response, which is nothing but ds of t by dt. ds of t by dt. So finally everybody is getting the option A, which is absolutely wrong answer. So many people think that why can't it be A? It is as simple as that. The differentiation of cos omega naught t is nothing but minus omega naught t sin omega naught t. So that is going to be option A. Why can't it be option A? Because it is not simply cos omega naught t, it is cos omega naught t u of t. That means it is a function of two, that is, one is cos omega naught t, another is nothing but u of t. There are two functions we are having. That means uv formula we have to apply. That is nothing but differentiation of uv, which is nothing but du v du plus u dv, like that. So option D is going to be the correct answer. How? Let's see. Check it out. First I am differentiating cos omega naught t, which is nothing but minus omega naught sin omega naught t u of t. Now I am differentiating u of t. cos omega naught t. The differentiation of u of t is nothing but delta t. We know from the product property of impulse function, delta t cos omega naught t. If any function multiplied with delta t, then t has to be replaced with 0. If I replace t with 0, this is the formula what we know, that is x of t delta t, which is x of 0 delta t. So this one what we are using here, that means cos omega naught t delta t, that is nothing but cos omega naught into 0, that is nothing but 1. Finally, this is minus omega naught sin omega naught t u of t plus delta t plus delta t. Option D is correct. Be careful what they are asking. So if you do any silly mistake in the GATE examination, you will always end up with option A. So that's what they will do. So they will prepare the option A in such a way that most of the people can do a silly mistake there and they can get the option A. So be careful when you get option A. Okay, take it. Question number 31. A discrete time LTI system, produces 1, 2 when unit step is applied. When unit step is applied. Full stop. Find the response when input x of n is equal to 2, 4. Okay. Okay. First, try to understand the question. A discrete time LTI system produces this kind of output when unit step is applied. That means when unit step is the input, this is the output. That is nothing but the step response what they have given. That means when unit step is applied means step is the input, unit step is the input. Then the output what we are going to get is nothing but the step response. So here this is the clue, unit step. So this is nothing but step response. So I can say they have given S of n. That is step response 1, 2. And they have given x of n, which is 2, 4. So many people think that yes, we know step response and x of n, we can do the convolution, I can get the output. No, convolution does not say you require step response. What the convolution said, if you know input and impulse response, then you can calculate the output, but not with step response. I hope you understood what I am trying to say. So with step response, I cannot directly find out the output when the input is known. So first we have to calculate impulse response from the step response, then only we can go and find the output. How we can do that? Let's see. We know the relation between step response and impulse response. What is that? H of n. Suppose if we try to find out h of n. What is h of n? Which is difference equation of s of n. Difference equation of s of n means s of n minus 1 minus, sorry, s of n minus s of n minus 1. S of n minus 1. So we have to subtract these two signals. So what is S of n? Which is 1, 2. What is S of n minus 1? We have to delay 1 unit. So it is 0, 1, 2. This is what S of n minus 1. So if I subtract them, I can get h of n. If I subtract them, so what we are going to get? H of n. How much? 1 minus 0, 1, 2 minus 1, minus 2. So this is what the impulse response. Now I got the impulse response and input. How we can calculate? I told you the multiplication method, how to find out the output of discrete time signals are given. So which is nothing but, let's say h of n directly I am writing 1, 1 minus 2, 2, 4 is the input. 2, 2 minus 4, 4, 4 minus 8. 2, 6, 0 minus 8. So this is what the output y of n. And we know where to put the arrow. That is nothing but h of n, x of n. Lower limits are 0, 0. So the lower limit of y of n is also 0. So this is where we can put arrow. Okay, take it. Convolution by integration method. Convolution by integration method. Convolution by integration method. Let's see how we can do this. For that, I will take an example. E power minus at u of t convolution with e power minus bt u of t. So after some time you have to remember this result, e power minus at u of t convoluted with e power minus bt u of t. What is the result it is going to be? You have to remember. But let's see, first we will go with the derivation, how we can do this. So I am directly applying the integral minus infinity to infinity e power minus a tau u of tau, that is x of tau. Next, h of t minus tau, wherever t is there, that has to be replaced with t minus tau. Then this is going to be e power minus b t minus tau u of t minus tau d tau. Okay, now I want to remove this u of tau u of t minus tau. So let's see how they are going to look like. U of tau with respect to tau. This is how they look like. U of tau curve. U of t minus tau, that is also called as u of minus tau plus t. So if t is positive, we are going to get this kind of thing. If t is positive. Now if I multiply these two, u of tau, u of minus tau plus t, where the limits are existing, so up to 0 this value is 0, so it is going to be 0. After t this value is going to be 0, so this is going to be 0. So only we have to consider between 0 to t. So if I multiply them, the result is existing u of tau, u of minus tau plus t is existing only between 0 to t. So that is also when t greater than 0. That is when t greater than 0. So I can remove these two terms, u of tau and u of t minus tau. Then I have to change the integration limits are from 0 to t e power minus a tau. This e power minus bt minus tau can be represented like this, e power minus bt into e power b tau d tau. So if you observe carefully, the integration is with respect to tau, then e power minus bt is a constant. We can take it out from the integration, e power minus bt integral 0 to t. We can club these two, e power b minus a tau d tau. that is equal to, this is a different story. What is that equal to? So what is the integration of e power b minus a tau d tau? What is the integration for this? E power minus bt into e power b minus a tau by b minus a 0 to t. So this is going to be e power minus bt then by b minus a. First, if I substitute t, e power b minus a t minus 1. If I multiply with e power minus bt, this is e power bt get cancelled, e power minus at minus e power minus bt by b minus a. But this is existing only for t greater than 0, because we already seen that for t greater than 0 only this is going to exist. So in short, we can write this is going to be e power minus at minus e power minus bt by b minus a into u of t. Why u of t? Because it is existing only for t greater than 0. Okay, take it. If a is equal to b, that is e power minus at u of t convolution with e power minus at u of t. What is the result we are going to get? Okay, try to understand. Again, I can go with the integration minus infinity to infinity e power minus a tau u of tau convolution with multiplied with e power minus a t minus tau u of t minus tau d tau. So again, if I remove u of t and u of t minus tau, I can get the limits from 0 to t e power minus a tau e power minus at e power a tau d tau. So here we are having e power minus a tau, here we are having e power a tau, get cancel each other. Then finally, if I take, this is at e power minus at taken out common, 0 to t d tau. So if I integrate this one, this is going to result into t. So t e power minus at for t greater than 0. So this is all about for t greater than 0. So finally, I can say this result is nothing but t e power minus at u of t. I have written u of t because it is only for t greater than 0. Next, what if a is equal to b is equal to 1, a is equal to b is equal to 0. So if a is equal to b is equal to 0, so that means if a value 0, b value 0, that means again we will take this value is also 0. U of t convolution with u of t, here also this is going to be 0, that means it is 1, t u of t, which is nothing but r of t. This is already we know that is u of t convolution with u of t, that is equal to t u of t, which is nothing but r of t, This is already we know it. Okay, take it. Let's say a power n u of n convolution with b power n u of n. What it is going to be? Okay, so let's see. I can write summation k is equal to minus infinity to infinity a power k u of k into b power n minus k u of n minus k. And again, if I remove u of k and u of n minus k, I have to take the limits. K is equal to 0 to n a power k b power n b power minus k. So here b power n is a constant with respect to k, so I can take it out from the summation. B power n summation k is equal to 0 to n. This can be written as a by b whole power k. A by b whole power k. Then what is the summation value? We know from summation, if summation n is equal to 0 to infinity a power n, which is nothing but 1 by 1 minus a. When this is going to be possible? If mod a less than 1. If mod a less than 1. And summation, finite summation, that means n is equal to 0 to some capital N, a power n. So it is not required for this one, mod a less than 1. So we can directly write 1 minus a power n plus 1 by 1 minus a. This is the one way. Or we can write a power n plus 1 minus 1 by a minus 1. A minus 1. So this is also another way. So any of the way we can write, because just what I have done is I have taken minus is the common out and we have cancelled each other. Then we are going to get the lower one. Okay. So this is what we have to use because it is a finite summation. Then this is going to be b power n a by b whole power n plus 1 minus 1 by a by b minus 1. So this all, suppose if I take b power n into the bracket and a by b minus 1, if you do that, you are going to get a power n plus 1 minus b power n plus 1 by a minus b. This all possible when n greater than or equal to 0. When n greater than or equal to 0. That means I can rewrite, or simply we can remember, a power n plus 1 minus b power n plus 1 by a minus b u of n. U of n. Okay, take it. Here also, what if a is equal to b? What it is going to be? Still, it is not going to be undeterminate. So if you substitute directly a is equal to b in this result, that is going to say undetermined, but it is not the correct answer. Let's see. If a is equal to b, if a is equal to b, that means we have to calculate a power n u of n convolution with a power n u of n. Again, if I do the summation k is equal to minus infinity to infinity a power k u of k multiplied with a power n minus k u of n minus k, u of n minus k. So if I remove this u of k, u of n minus k, this is going to be summation k is equal to 0 to n a power k, a power n, a power minus k. A power minus k, a power k get cancelled finally. If you take a power n out, k is equal to 0 to n 1. So how many ones are there from 0 to n? Which is nothing but n plus 1. So n plus 1 a power n for n greater than 0. For n greater than 0. So finally this is nothing but n plus 1 a power n u of n. I can write n plus 1 a power n u of n. What if a is equal to b is equal to 1? If a is equal to b is equal to 1, that means u of n convolution with u of n. So we already know this. This is going to be n plus 1 u of n. N plus 1 u of n. Take it. Summary. First, let's say for continuous time case. Next, we will see for discrete time case. Discrete time case. Let's see one by one. First, e power minus at u of t convolution with e power minus bt u of t. What we are going to get? E power minus at minus e power minus bt by b minus a u of t. B minus a u of t. Next, if a is equal to b, then e power minus at u of t convolution with e power minus at u of t. This is going to be t e power minus at u of t. Next, if a is equal to b is equal to 0, then u of t convolution with u of t, we are going to get t u of t, which is r of t, which is r of t. In the similar manner, for a discrete time case, a power n u of n convolution with b power n u of n. This is going to be a power n plus 1 minus b power n plus 1 by a minus b u of n. A minus b u of n. So here it is not b minus a, it is nothing but a minus b only. Next, if a is equal to b is equal to 1, sorry, a is equal to b, then it is a power n u of n convolution with a power n u of n. So this is going to be n plus 1 a power n u of n. Next, what if I take u of n convolution with u of n, which is n plus 1 u of n, that is n u of n u of n, that is r of n plus u of n. Okay, take it.